This is a University of Lethbridge Department of Mathematics and Computer Science CPSC 2610 video by Nicole Wilson. In this video we'll look at how to complete question 1c of lab exercise 0, the sample lab. So as you may recall from previous videos, question 1c asks us to consider the Boolean expression x NAND y or not x and not y. And in part C, we're asked to draw a wiring diagram for the Boolean expression. So in our answer sheet, just below the logic circuit, we want to make a wiring diagram. In a wiring diagram, we have to take into account everything that is an issue when we go to wire the circuit. So remember in the logic circuit, we weren't all that worried about the fact that we had 5 inputs on these gates. When we're actually hooking up the chips, we have to use every input for each gate on a chip. Not every gate on the chip, but each gate's inputs have to be used, or we get strange results. So we'll talk about that more when we do the video on actually making the circuit. So you have been given a file called altchips.jpg. It's on the Moodle page. Do not download the individual document of the JPEG because it gets corrupted sometimes when you download it and you lose some of the sharpness of these diagrams. Instead, make sure that you download the zipped file and unzip it. This will preserve the size of this image without any changes. There are other ways to do that, but I can guarantee it with the zip. So these are all of the chips that we have in our chip set. There's quite a few of them. If I zoom out, you can see how large all of this is. So there's quite a few of them there. For what we're doing, we need to grab 2 switches. So these are our switches. I'm going to copy those and bring them over into a blank document here. So this is just a paint document. On the Linux side, you can use color paint. Then remember, we need an inverter chip because we are going to find the inverse of both of those things to go in. So we've got NOR hex inverter here. So I'm just going to zoom out a little and a little more. So there's our hex inverter. I've made a slight mistake here. I do not have transparent selection turned on, and so when things overlap, they're overwriting. Okay, so there's our hex inverter. We also need a NAND with 2 input NANDs and an AND with 2 input ANDs. So there's our AND, and the NAND, I think, is further back. Yeah, there's the NAND. So I'm going to grab this NAND. And then I need the AND. Then we need an OR gate, as you may recall. So that's a NOR, that's not going to cut it. We need an OR. And triple NOR, there's our OR. Copy that into place. And lastly, we need an LED for our output, but we only need 1 of them. So I'm going to just copy 1. If this, actually, let's set it up the way I would a bigger one. these down, and if there's more than one, line it up. Okay, so I have an X and a Y here. I haven't left myself much room for labeling, so I'm going to zoom out and move things around a little. Scoot it down a bit. So first thing I need to do is some labeling. So I hit this and I'm going to go in and make an X. I prefer to have it be italicized and Times New Roman, but really I'm just happy if you label. So I'm not that worried about it. And Y. And then to give myself a little more room to work with, I'm taking a selection of both wires. Oops. That didn't look very impressive. Here we go. And we're dragging the bottom down to just extend those lines so we can go across wherever we need to. Okay, so going across, we know we need to hook both the X and the Y up to the NAND, so I'm going to take a line tool and I'm just going to go across. And if you hold the Shift key down, it'll make a straight line. So go right to where you want. We're going to put solder points in later. These become important later on in the course when we're making much more complicated wiring diagrams. If you want to zoom out a bit so you can see better what you're doing, you can. So there, I've hooked up the X and the Y to the NAND. And then I need a not X. So I'm actually going to, so let's put some solder points in right away. I'm going to make my solder points in dark green. I'm going to use circles for them. So I'm putting a solder point here. Oh, that wasn't filled. We also want it to be filled with green. So again, I'm going to hold the Shift down to get a perfect circle. So there's what I'm going to use for solder points. And I'm going to just put them in place. Copy that. Oops. So what went wrong there is I didn't change my background color back. Okay, so there's my solder point. And then I need another one. And this is why you need the solder points. I need to hook X up to one of these inverters. I've already got it going right through, so what I can do is just put a solder point here as well to indicate that's also hooked up. Similarly for the Y with the second inverter. And then anywhere we branch where it's actually hooked up, we want a solder point. You will lose marks for not having these because it's pretty hard to tell the difference between passing through and connected without them. Okay, so now I've got the X hooked up to the NOT or the inverter, so I'm going to hook that up to the AND. So again, I'm holding the Shift key down. Uh-oh, I've got green. Fact is, you want to do color, I don't actually care, but I have decided to do black here. And in fact, again, later in the semester, you may find it's really handy to do some of this stuff in color. So I've got not X, and here's my not Y, also getting hooked up to the AND. So I'm going to put in some more solder points. Now I have to hook the NAND and the AND up to the OR gate. So again, I'm going to go get a line. Here's my NAND down here. Hook that up to the input for the OR. And then this is the output from my AND. I'm going to hook up to the second input for the OR. And again, put in some solder points. where they need to be. The important thing here is not we have some kind of perfect drawing, it's that we can trace and follow these easily, which is why many people like to use color in them. And that when I see it, or your lab instructor if you don't have me this semester, that it's pretty clear what's connected where. Anything else we call spaghetti, and if you hand in spaghetti, you get marked like you handed in spaghetti. Don't expect it to be worth much. And now we hook it up to the LED. So what we've done here is we've identified which chips we need and how we're going to hook them up to the switches and also to the LED output. And we use this wiring diagram when we actually wire. Some people like to print it out. So I'm going to zoom out so I can see the whole thing. Control A selects the entire thing so I can kind of shift things over. And then I'm going to make my window a little bit smaller. Go back to 100%. Again, Control A to select the whole thing. Control C to copy, and now I go back to my Word document and paste it in. I think this is quite legible at the size it is right now, but if for some reason it wasn't legible, by all means make it, you can flip it sideways and put it on a page by itself. So that's making a wiring diagram.